Hi everyone. So in this video, we're going to learn a procedure called polynomial long division, and we'll see how polynomial long division is actually related to finding zeros of polynomials. So I'll introduce to you how polynomial long division works in a little bit, but what we'll see is that it actually operates fairly similarly to long division of numbers. So if you remember how to do long division with numbers, I think that's really going to help you to transition more smoothly to long division with polynomials. So I want to give you kind of a warm-up problem, and I would really encourage you to pause the video and try this yourself. So what I want you to do is use long division to divide. So we're going to do 583 divided by 4. So I'll start by setting this up just to remind you how like the notation usually looks. So usually if you've learned long division in the United States, you write it like this, 583 divided by 4. I should mention that if you learned long division in a different country, a country other than the United States, you may actually use a different symbol, but the procedure is the same. So I'm not really familiar with the different symbols used in all the different countries, but if you're looking at this and you're like, we used a different symbol for long division, that's fine, and you can use a different symbol, but just know that this is what I'll be using in this class. So pause the video, try to see if you can remember how this works yourself. It might be a while since you've done this, so make sure that you remember how it works. Okay, so how does this work? How do you do long division? Well, the first step is taking your number that you're dividing by and seeing how many times it goes into the first number here. So how many times does 4 go into 5? Well, it only goes in one time. So I'm going to put a 1 up here. And so then what do we do next? Well, we multiply 1 times 4, right? So I multiply 1 times 4 and I get 4 and I put that below here. And then you subtract. So we do 5 minus 4 and we get 1, and then we bring down the next digit, which is 8. The next thing we do is we take 4 and we divide it into 18. So how many times does 4 go into 18? Well, it goes in 4 times. And then we do 4 times 4 and we get 16, and we subtract that from 18. And so 18 minus 16 is 2. We bring down this digit here, so that's now going to be 23. And then we see how many times does 4 go into 23? Well, it goes in 5 times. And so then we do 5 times 4 and we get 20. We subtract the 20 and we get 3. So I want to talk a little bit before we get into polynomial long division about how do you interpret this answer? What are some different ways of expressing this answer? So one way that you could write it is you could say that 583 divided by 4 is equal to 145, right? That was the answer we got. And then the remainder is that extra number that was left over at the end, right? Remainder 3. And I'm going to color code this. But that's not the most descriptive way of writing that. I mean, you kind of get a sense of what the remainder is telling you. But a nicer way of writing this would actually be the following. You instead could say that 583 divided by 4, which, by the way, there's actually another way of writing that, which I think might even be nicer. You could also write it like this, right? Instead of writing the division symbol, you could write divided by 4 like that. And then we can say is equal to 145. And then how could we express the remainder as like a fraction? Like what would be a kind of more specific way of saying a remainder of 3? Like 3 what? What does that 3 represent? Well, it's 3/4, right? Because that's what you were dividing by. So another way of expressing this answer is you could say 583 divided by 4 is 145 plus 3/4. And you could check that this is true, because if you make a common denominator, if you make a denominator of 4, you should find out that 145 plus 3/4 is equal to 583 over 4. So just a couple things I wanted you to get familiar with. There's two different ways, right? There's the remainder. There's also this idea of putting your remainder over the divisor, over the number you're dividing by. And then the other thing that I think is always useful to be familiar with is that these two things are the same, right? Dividing by 4, you can write it as a fraction, or you can write it as just division. Okay, so let's now get into polynomial long division. So polynomial long division is something that, I would say that a good number of students find it kind of challenging. I'm not saying that to scare you, I'm just saying that to kind of set the expectation that, it's okay if at first it seems a little tricky. What I think is really important is practice. I think more than other topics, this is one of those topics that you really have to practice it. If you don't practice, you're not going to get that muscle memory that allows you to do the procedure efficiently. So I'm going to write down a polynomial long division problem. And I'm going to use the same kind of color coding because I think it will maybe help you connect to what happened up there. So we're going to divide the polynomial 2x squared minus 5x minus 1. We're going to divide that by x minus 3. So I used blue, I think, right? X minus 3. So we're going to do a division problem, and we're going to set it up pretty much the same way that we did the other one. So I'm going to make this kind of division bar. I'm going to put the one that's being divided on the inside. And I'm going to put the one that we're dividing by on the outside. Okay, so how does this work? Well, it's really kind of the same idea we did before, right? What was kind of the pattern when we're doing regular long division? You're always taking the number you're dividing by and kind of dividing it into this, and then doing a multiplication, bringing it down, and then you're dividing into something else. And it's really going to follow that same pattern. There's one key difference, which is that when we're doing the step of kind of dividing something into something else, you don't need to focus on this entire x minus 3. You only have to focus on x. So the first step that we're going to do is we're going to divide 2x squared by x. Just like how above, right? The first step was really doing like 5 divided by 4, right? It was saying how many times does 4 go into 5? Another way of saying that is 5 divided by 4. And so here we're saying how many times does x go into 2x squared? Another way of saying that is 2x squared divided by x. So what would we put up here? What is 2x squared divided by x? Well, it's 2x. Okay, so based on how we did the regular long division, what does it seem like should be the next step? Well, in regular long division, we do a multiplication next, right? We write something down here and we subtract. And that's exactly what we're going to do in this case. So we're now going to take this 2x and we're going to multiply it with x minus 3, and we're going to write the result below. So 2x times x minus 3, we get 2x squared, and then we get minus 6x. Right? That comes from 2x times x minus 3. Then we want to take this and subtract it. And so this is one place where students, I think, are very prone to making errors. So pay attention here. When you subtract this, you need to make sure you're subtracting the whole thing. So there's two different ways of writing it. You can either put subtraction like this with parentheses, or my preferred method is to just distribute that negative sign in. So to say, okay, this is minus, but then I'm also putting the negative sign in here, so this is becoming plus. Maybe I'll leave that this part so that you can see originally it was minus, but we made it plus, right? And so now we just subtract and we write down the new polynomial below. So 2x squared minus 2x squared, well, that's 0. So you're generally always going to get 0 because you picked this to be the right number to give you 2x squared, right? Like that's why we put a 2x there. Okay, and then next we have negative 5x, and we're adding 6x to that. So that's going to be plus x. And then this is a little different from the regular long division. We also just bring down the next part. So we bring down that 1. Okay, so now we have x minus 1. And so now we repeat the process, but we're saying how many times does x go into x, right? The first step was how many times does x go into 2x squared. Now it's how many times does x go into x. And so how many times does x go into x? Well, only once. So we say plus 1. And then just like we did in the last step, we do this multiplication step. So we take this and multiply it with this and write it down below. So what is 1 times x minus 3? Well, that's just going to be x minus 3. And then we need to subtract. So we make this minus and this becomes plus. And so we're left with 0, right? X minus x is 0. And then here we have negative 1 plus 3. So that is going to be plus 2. And that's it. So once you're to the point where you can no longer do like x into 2, right? That doesn't make sense. Basically, as soon as the degree of the thing you're trying to divide into is less than the thing you're dividing by, that means you're done. And so now there's two different ways of expressing this answer, right? We can either say that 2x, or sorry, let me write out the thing we're dividing first. So 2x squared minus 5x minus 1 divided by x minus 3 is equal to 2x plus 1 with a remainder, right? We found a remainder. Sorry, my screen is a little stuck. And that remainder was 2, right? That's what we had left over at the end of the day. What would be another way of writing that? Well, we could instead say it like this: 2x squared minus 5x minus 1 divided by x minus 3 is equal to 2x plus 1. And then how can we express our remainder? Well, it's not just 2, it's 2 over x minus 3, right? Because that's what we were dividing by. That's really like you can think of the thing you're dividing by as kind of your units, right? That's saying you're counting how many of those fit into your polynomial. And so if you have 2 left over, it represents 2 x minus 3s, basically. Okay, so that is how polynomial long division works. I know that if this is your first time seeing this, you probably need more practice, so we're going to do a couple more examples. I will say that polynomial long division is supposed to be a prerequisite for this class. You are actually supposed to have learned this before. I have found that most students have not learned this before, so that's why I take the time to go over it. But if you've never seen it before, you probably will need to seek out like a little bit of extra practice beyond this video. There's plenty of, if you just Google like polynomial long division worksheet or polynomial long division on YouTube, you'll find plenty of examples. Okay, so the next example that I wanted to do is let's do x cubed minus 8x plus 5 divided by x plus 2. Okay, so there's something a little bit different with this one, which is that notice that the polynomial that we're dividing, it doesn't have an x squared term. And so this is really important. If the polynomial that you're, either of the polynomials actually, is missing a term, so if it kind of has a power of x that just isn't there, then you're going to need to put in kind of a placeholder. So what I mean by that is when we go and write this in our long division setup, instead of just writing x cubed minus 8x plus 5, I'm going to write x cubed plus 0x squared minus 8x plus 5. And what we'll see is that basically just kind of makes sure that things line up correctly when we go through and do this process. Okay, so let's remember how this process works. So the first thing we want to do is divide x into x cubed. So x cubed divided by x is x squared. The next thing we want to do is we want to take x squared and multiply it with x plus 2 and then write the results below. So x squared times x plus 2 is going to give us x cubed plus 2x squared. So that's why it's important, right, that we have this 0x squared there. That way things will kind of line up correctly when we do the subtraction step. So now we want to subtract this. So that means that we want to make both of these negative, right? We have to distribute that negative sign to both. And so we get 0 for this first part. And generally you don't have to write that down because like I said, you're just always going to get 0 if you did the division correctly in the first step. But what we do get here is we get negative 2x squared. And then we bring down the rest of this, right? Minus 8x plus 5. And so next we're going to do x divided into negative 2x squared. And so that is going to give us negative 2x. And so now we take x plus 2 and we multiply it with negative 2x and we write the results below. So we get negative 2x squared minus 4x. And now we have to take that quantity and subtract it. And so that means that this is going to become plus actually, right? And this is going to become plus. So you're always just flipping the signs of the whole thing. And so what are we left with in this case? Well, the 2x squareds cancel out, and that's good. And so what we're left with here is negative 4x plus 5. And so now we want to divide x into negative 4x. So that would be negative 4. And so now we multiply negative 4 times x plus 2, and we write the results below. So that's going to be negative 4x minus 8. And then we need to subtract. So this is going to become a plus, and this is also going to become a plus. And so what are we left with as a remainder? We're left with 13. And so this tells us kind of two different things. We can either say that x cubed minus 8x plus 5 divided by x plus 2 is equal to x squared minus 2x minus 4 with a remainder. I'm just going to write remainder as r, remainder of 13, or what's I think the better way of expressing it is that x cubed minus 8x plus 5 divided by x plus 2 is equal to x squared minus 2x minus 4 plus 13 over x plus 2. And when I'm saying this is better, it's basically just more descriptive, right? It actually tells you like this, what we just wrote down here, this is like a true statement. Again, if you made a common denominator, so if you multiplied this fraction by x plus 2 over x plus 2 and added it together, you would get exactly this one. Whereas this is a little more vague, exactly. Like I have a hard time understanding exactly what that remainder really means in that context. Whereas here you can really see that it's a mathematically true statement. All right, I want to do one more example, and this one is going to bring up something a little different. So even if you're comfortable with the last couple of examples, please watch this one as well. So in this case, we're going to do x cubed minus 8x squared plus 19x minus 12, and we're going to divide that by x minus 1. So in this case, we don't need to worry about that placeholder business. We have all of the different powers of x. We don't skip any. So we're doing that divided by x minus 1. Okay, so first we divide x into x cubed. And I would definitely, I said to watch this, but as with all the examples, I would encourage you to pause and try it yourself first. Just because, I think it will be pretty boring to just watch me do this, but if you do it yourself first, then you can see like where you might have gotten stuck and come back and rewatch that with a little bit more kind of focus for what you're looking for. Okay, so we're going to divide x into x cubed. Our answer is x squared. And so now we multiply x squared times x minus 1 and write the result below. So that's going to be x cubed minus x squared. Then we want to subtract this, right? So this is going to be minus and this is going to become plus. And so the x cubes are going to cancel out as they should. And here we're going to be left with negative 7x squared. And then we bring down the 19x minus 12. Okay, so next up we have, we're going to be dividing x into negative 7x squared. So that's going to be minus 7x. And so now we're going to multiply together negative 7x times x plus 1 and write the results below. So that's going to be negative 7x squared plus 7x. And now we need to subtract everything, so this will become plus and this will become minus. And so we're going to be left with, when we do that, 0. The 7x's cancel, or 7x squareds cancel out, and then we're left with 19 minus 7 is 12. So we have 12x minus 12. And so now we're dividing x into 12x. And so that's going to be 12. And so now we multiply 12 times x minus 1 and write the result below. So that's going to be 12x minus 12. So you might start to see what's going to happen in this case. So what happens here is that when we subtract this, well, actually both terms cancel out. And so we're left with a remainder of 0. So what does it mean to have a remainder of 0? What does this tell us? So I want to think for a moment about just numbers. So I'm going to give kind of a simple example. So let me just kind of write this down. What does it mean to get a remainder of 0? So let's just think about numbers for a second. So let's say, for example, you were doing 27 divided by 3. So if you were to do that out, you would get an answer of 9, right? And the remainder would be 0. So what does it mean that you would get a remainder of 0? Well, that means that it's a factor. So this would tell you that 3, this number 3, is a factor of 27. And a little bit more specifically, it tells you that 27 is equal to 9 times 3. Sorry if I may have gone overboard on my color coding here, but hopefully it's helping. Right, so if you get a remainder of 0 when you're doing division, that tells you that whatever you are dividing by goes in perfectly, meaning it's a factor. And when something is a factor, well, that means that you can then kind of rearrange your division, right? If 27 over 3 is 9, that means that 27 is equal to 9 times 3. So let's try to reinterpret that in terms of this. You know, what does this tell us? Well, this tells us that x cubed minus 8x squared plus 19x minus 12 divided by x minus 1 is equal to, sorry, I don't know why my screen keeps getting stuck today. So what do we get as our answer? We got x squared minus 7x plus 12. And so what does that tell us about our original polynomial? Well, it tells us that x minus 1 is a factor, right? It went in perfectly. And so that tells us that x squared minus 8x, or sorry, x cubed minus 8x squared plus 19x minus 12 can actually be written as x squared minus 7x plus 12 times x minus 1, right? So this is going to be a really important idea. So I want you, if you don't quite get this, I want you to pause and reflect on it and go back to the example with the numbers and really think about it until it makes sense to you, because it's really important for you to understand the rest of it, that this part clicks. So if we're dividing by x minus 1 and we get no remainder, then that means that x minus 1 goes in perfectly. It's a factor. And additionally, it means that now we actually know at least how to start to factor our polynomial. So why is this valuable? Well, if you think back to the last few videos, we've been factoring a lot, right? But typically when we've been factoring, we've been starting by factoring out x or x squared or x cubed or something like that. So far, we have not known how to factor something that looks like this, right? Why is this different? Well, notice it doesn't, the last term is a 12, so we can't just like factor out an x from everything, right? There's nothing that can be factored out from everything when you first kind of glance at this polynomial. And so what we've just learned is that polynomial long division actually gives us a way to start to factor something. And what's extra nice, and we'll see this in just a moment when we kind of delve more into this example. So once we started to factor this, once we factored out x minus 1, well, we actually know how to factor quadratics, right? Those we can factor. So by kind of getting the ball rolling by dividing by something, it enabled us to begin to factor our polynomial, and then we'll be able to factor the rest. So that's really what we're going to be doing for the rest of this video, is kind of taking use or making use of that idea. Okay, so what is the kind of premise going to be? What is the question we're going to be asking? Well, we're going to go back to finding zeros. So I'm actually going to use the same polynomial, and then we'll do some other examples from scratch so that you can see like how this process goes from start to finish. But we already know some stuff about this polynomial, so I want to show you right away how we can make use of that. Let me just make sure I copied that down right. Was it minus 8x plus 19x? Okay, cool. Okay, so how do we find zeros of a polynomial in general? Well, we take the polynomial and we set it equal to 0 and we try to solve, right? So we have x cubed minus 8x, oh, I know what I forgot, squared. Minus 8x squared plus 19x minus 12 is equal to 0. So typically, this is not one that we would be able to factor, right? But from the last page, we found out that this polynomial can be factored as x minus 1 times x squared minus 7x plus 12. I would not expect you to be able to just see that, from scratch, but because we did this polynomial long division, that's how we know it. So maybe I'll make a note of this. This was from the long division on previous page. In case anyone is looking at these notes, they'll know where that came from. Okay, so what can we do from here? Well, now we already have one factor, right? So we're going to be able to find 1 0, but then we can continue to factor. So we can factor this now as x minus 1 times, so x squared minus 7x plus 12, that factors as x minus 3 times x minus 4. And so now we can find all the zeros, right? We can say x minus 1 is equal to 0, so that means x is equal to 1. X minus 3 is equal to 0, that means x is equal to 3. X minus 4 is equal to 0, that means x is equal to 4. And the multiplicity of each of these is 1, right? Because each factor only appears one time. So I want to pull up the graph of this real quick just so that we can actually see this, verify this fact. So we got 1, 3, and 4, and each of them are multiplicity 1, so we should expect the graph to pass through at each of those points. So here we have the graph of our function, and we can see that we have zeros at 1, 3, and 4. And you can also see the end behavior looks like what we'd expect, right? It goes from kind of bottom to top because of the odd power, odd degree, and positive leading coefficient. Okay, so how are we able to do this? Well, we had to make use of the fact that we already did long division. So what we'll see in the next couple examples is that in order to do these problems, you have to be kind of handed this piece of information about what to divide by. Otherwise, you wouldn't know, how to get started with this long division. So in this next problem, we're going to look at the polynomial g of x is equal to 2x cubed plus 4x squared minus 2x minus 4. So we're going to do two things. We're going to start by showing that -1 is a 0 of this polynomial. And then we're going to find all other zeros. And I should mention that some of you might know how to factor this. So this actually can be factored using grouping. And I'm not going to go into how to use that method, but because this other method will work just fine. But some examples you might be able to factor. You might be able to see kind of a clever way to factor them. But other examples, like I'd say the previous one, would be a lot harder to just kind of see a way to factor it. Okay, so how can we show that -1 is a 0? How do you show that something is a 0 of a polynomial? Well, you can plug it in, right? So if -1 is a 0, and maybe I'll number these so we can keep track of what we're doing where. So how do we show that -1 is a 0? Well, we can just plug in -1. So we would get 2 times -1 cubed plus 4 times negative 1 squared minus 2 times negative 1 minus 4. And so that's going to be equal to 2 times negative 1, so that's negative 2, plus 4 times positive 1, so that's 4, minus 2 times negative 1, so that's going to become plus 2, minus 4. And so we can see we have minus 2 plus 4 minus 4, and so that equals 0. And so we have showed that it is in fact a 0. Okay, so how can we find all the other zeros? Well, this really comes down to understanding the relationship between zeros and factors. So if negative 1 is a 0 of g of x, then what must be a factor? And what do we know has to be a factor? Well, x plus 1 should be a factor, right? Because we know that if c is a factor, then x minus c, or sorry, if c is a 0, then x minus c is a factor, and so that would give us x plus 1. And so if x plus 1 is a factor, well, that means that g of x can be written as, and actually let me write it this way. So g of x was equal to 2x cubed plus 4x squared minus 2x minus 4. So if x plus 1 is a factor, that means that we should be able to write our polynomial as x plus 1 times some mystery polynomial, right? And so how can we find that mystery polynomial? Well, if we take 2x cubed plus 4x squared minus 2x minus 4 and we divide it by x plus 1, that will tell us what that mystery polynomial is. So this is going back to the idea that we talked about on this page right here, right? This idea that division and multiplication, you can kind of rewrite the same idea two different ways. And so what we're going to do is we're going to do polynomial long division. We're going to take 2x cubed plus 4x squared minus 2x minus 4, and we're going to divide it by x plus 1. Okay, so first we divide x into 2x cubed, so that is going to give us 2x squared. Then we're going to multiply together x plus 1 times 2x squared and write that below. So that's going to be 2x cubed plus 2x squared. Then we're going to subtract that. So this is going to become minus. This is also going to become minus. And so we're going to be left with here 2x squared minus 2x minus 4. And so now we're going to be dividing x into 2x squared. So how many times does x go into 2x squared? Well, that would be 2x. And so now we multiply together 2x times x plus 1, and we get 2x squared plus 2x. That's it. Sorry, 2x squared plus 2x. And then we subtract. So we do minus, and this becomes minus. And so now we're left with the 2x squareds cancel out, and so we're left with negative 4x minus 4. And so now we want to divide x into negative 4x, and so that's going to be negative 4. And then we multiply negative 4 with x plus 1. And so we get negative 4x minus 4. And so what is that going to give us when we subtract? Well, these both become plus and we get 0. And so when you're doing these types of problems where you know that something is a factor, you should always get 0 as a remainder. If you get something else, that tells you you did something wrong, right? We already verified that negative 1 was a 0, so we know that x plus 1 has to be a factor. So if you do the long division correctly, you really ought to get 0 as your remainder. All right, so what does this tell us? This tells us that our function g of x can be written as x plus 1, that was what we were dividing by, times our answer up here, right? 2x squared plus 2x minus 4. Okay, so how do we go from here? Well, if we're trying to find the zeros, and that's, I think, what we kind of started by, or that's what we're ultimately trying to do, right? We're trying to find all the zeros. Well, that means we have to set our function equal to 0, right? That's what we generally do when we're finding zeros. And so now we're left with something that we do know how to factor, right? So we can start by factoring out a 2 from everything, because that will just make things a little easier to factor. So we can factor 2 out from everything and bring that out to the front. And then you can actually just divide both sides by 2. So if we divide both sides by 2 and then we factor this remaining piece, we'll be left with x plus 1. And then how does x squared plus x minus 2 factor? Well, that's going to be x plus 2 times x minus 1. And so from here we get 3 zeros. We get x is equal to negative 1. And so that is going to have a multiplicity of 1. And then we get x is equal to negative 2. And that's going to have a multiplicity also of 1. And then we also get that x is equal to positive 1. And that's also going to have a multiplicity of 1 because each factor only appears one time. So let's just take a quick peek at the graph to verify that we got these correct. So here is our function. Oops, I made a typo. Let me fix that. I was like, that doesn't look right. I somehow added in a 1 there. Okay, this looks better, right? So we see that we have zeros of negative 2, negative 1, and 1, which is what we expected. And each of them passed through because they had multiplicity 1. Okay, so we're going to do one last example, and this one is, I think, a little bit trickier. So in this case, our function is going to be h of x is equal to x to the 4th minus x cubed minus 7x squared plus 8x plus 4. So the first thing we're going to do is we're going to verify that 2 is a 0 of this polynomial. And then once we do that, we're going to assume, and we'll see that it's true. So given that 2 is not only a 0, it's a 0 of multiplicity 2. We're going to find all other zeros. So don't worry too much right now about this multiplicity business. We'll get to that when we get to step 2. For the first step, all we really have to do is just verify that when we plug in 2, we get 0. So same deal as earlier. So h of 2 is going to be 2 to the 4th minus 2 cubed minus 7 times 2 squared plus 8 times 2 plus 4. And so that is going to be equal to 16 minus 8 minus 7 times 4, so that's minus 28, plus 16 plus 4. And if you add those all up, you will find that you get 0. So it is, in fact, a 0. Okay, so now how do we make use of this multiplicity business? So on the last problem, we basically started by saying, well, if a certain number is a 0, then that tells us a factor, right? So if 2 is a 0, but it's not just a 0, it's a 0 of multiplicity 2. So what does that tell us has to be a factor? So not just x minus 2. It is true that x minus 2 is a factor, but we can do better than that. X minus 2 squared has to be a factor, right? If it's a 0 of multiplicity 2, that means that it's actually x minus 2 squared. And so when we go to do our division like we did on the last one, we're going to want to actually write this out. So what's another way of writing x minus 2 squared? Well, that's x squared minus 4x plus 4. Because when you're writing your polynomial in its factored form, you're probably going to write it like this. But when you're doing polynomial long division, we want it to look like this. Okay, so let's remind ourselves of how this polynomial division gets set up. Basically, the idea is that, so the big polynomial we have is x to the 4th minus x cubed minus 7x squared plus 8x plus 4. And the idea is that if we know that x plus 2 squared is a factor, so x squared minus 4x plus 4 has to be a factor, then that means that we can rewrite our polynomial as that x squared minus 4x plus 4 times something. And another way of expressing that is x to the fourth minus x cubed minus 7x squared plus 8x plus 4 divided by x squared minus 4x plus 4. Well, that is going to give us whatever this mystery other factor is. And so that's the division that we're going to have to do. So another round of polynomial long division. This one, we're dealing with slightly higher powers of x. But we don't have to put in any kind of fillers because we have all the powers. We didn't skip any. Okay, so first we're going to do x squared divided into x to the fourth. And so that is going to give us x squared. Then we multiply, this time we have a little more to deal with because we're multiplying x squared with this whole thing. So x squared times all of that will give us x to the fourth minus 4x cubed plus 4x squared. And so next up, we need to subtract all of this. So this is going to become minus, this is going to become plus, and this is going to become minus. And so the x to the fourths cancel out, and here we have negative x cubed plus 4x cubed, so that's going to give us 3x cubed. And then we have negative 7x squared minus 4x squared, so that's minus 11x squared. And then we can bring down the rest of this. Okay, so next up we're going to be dividing x squared into 3x cubed. So that is going to be 3x. And so now we multiply 3x with all of this. And so that's going to give us 3x cubed minus 12x squared plus 12x. And then that's what we have to subtract. So this is going to become minus, this will become plus, this will become minus. And so the 3x cubes will cancel out. And so here we'll have an x squared. Then we have 8x minus 12x, so that's minus 4x. And then we have plus 4. And so now we're dividing x squared into x squared. And so that's going to be 1. And so now we multiply 1 with this divisor. And so we get x squared minus 4x plus 4. At this point, you can probably see how this is going to pan out. We subtract and everything cancels out. And so good, we got our answer. So this now tells us that our polynomial can be written as x squared minus 4x plus 4. That was the part we already knew. But now we have our answer here. So we know that we can, the other missing factor was x squared plus 3x plus 1. Okay, so now to find the zeros, now we want to take this whole thing and set it equal to 0. Okay, so we already know that this left side factors as x minus 2 times x minus 2. That's how we got it. But this next part, actually, we can't factor it with whole numbers, right? There's no numbers you can come up with that will give us that 1 and that 3x. And so we're going to leave that as is. And by now, hopefully you've realized that whenever we can't figure out how to factor something, that's where we use the quadratic formula. So from this part, we get x is equal to 2, right? That comes from both of these. And so that has a multiplicity of 2. But then for this part, we have to use the quadratic formula. So we have x squared plus 3x plus 1 is equal to 0. And then from here, we just solve with the quadratic formula. So we get x is equal to negative b, so negative 3. Sorry, I don't know why I wrote a 1. Plus or minus the square root of b squared, so 3 squared, minus 4 times 1, that's a, times c is also 1, all divided by 2 times 1. And so that is going to be negative 3 plus or minus the square root of 9 minus 4. Divided by 2. And so that is going to be negative 3 plus or minus the square root of 5 over 2. And so that can't really be simplified. But what we can say is that we have x is equal to negative 3 plus square root of 5 over 2. That's one of our zeros, and that has multiplicity 1. And then our other 0 is negative 3 minus square root of 5 over 2. And that has multiplicity 1 as well. So now we have our 3 zeros. So we had 2 of them with multiplicity 1 and 1 that had multiplicity 2. So I just want to point out, remember we talked about this thing called the fundamental theorem of algebra. So remember, if you add up all your zeros with their multiplicities, you should get the degree. So here we have 2 plus 1 plus 1, and the degree of our original polynomial was 4. So that's always kind of a good check to do. So let's just take a quick look at that graph. So we should see that we have a 0 of multiplicity 2 at 2, and so we see that. And then these other 2 zeros, these are what you would get if you plugged in the quadratic formula solutions into a calculator. These are the decimal approximations. And if we zoom out, we can actually see the whole graph, and we can also see that it has the same general shape that we would expect from the degree and leading coefficient. All right, so that is it for this video, and that is it for polynomials. So our next topic is going to be something called rational functions. So I'll see you all when we get into that.